This is a video for AQA Further Pure Mathematics. It's complex numbers, section 3.4, where we're looking at dividing complex numbers in modulus and argument form. Well, first of all, looking at the problem algebraically, you can see that if we've got two numbers z1 and z2 as given, then when we divide them, we get the expression r1 cos theta 1 plus I sin theta 1 over r2 cos theta 2 plus I sin theta 2. Now, as usual, when we're dividing complex numbers, then we can multiply by the conjugate of the denominator. Now, in this case, we simply need to multiply by cos theta 2 minus I sin theta 2, which gives this expression that we need to then simplify in the usual way by multiplying out the brackets. I'm going to leave that as an exercise for you to do. You might like to pause the recording and try it yourselves. And once you've done that, you should find that you get the following result. Now, just checking through that, the top line, the real part has come from the first term cos theta 1 cos theta 2, and then the final terms multiplied together, where you've got minus of I squared sin theta 1 sin theta 2. So that's where you get the plus sin theta 1 sin theta 2. Hopefully you managed to get that if you've tried it yourself. Now what I want to do is to concentrate on, well, what are these expressions? If you look at the first one, the real part of the top line, that's an expression for cos theta 1 minus theta 2. And the imaginary part is sin theta 1 minus theta 2. The bottom line, of course, cos squared theta plus sin squared theta is equal to 1. So this all simplifies down to the following expression, which we can consider now as a complex number where the modulus is r1 over r2 and the argument is theta 1 minus theta 2. So what's happened is that we've divided the moduli of the two numbers and we've subtracted the arguments, which gives us a nice simple way of doing division. Now, if you remember, of course, when you were multiplying, you multiply the moduli and you added the arguments. Here, the complete opposite. Dividing, you divide the moduli and subtract the arguments. So now I'd like to look at that in a numerical example. Here we've got two numbers, and you can see that in the first number there the modulus is 6 and the second one is 4. So when we divide these, then the modulus of z1 divided by z2 is 6 divided by 4, or 1.5. The argument of z1 is 5 pi by 6 and the argument of z2 is negative pi by 4. So we're going to subtract these, and if you do 5 pi by 6 minus negative pi by 4, you end up with 13 pi over 12. But of course that's greater than pi. So what's happened here is we've got the angle coming round in the positive direction here, round to this point. But we actually want therefore a number which is between negative pi and pi, so the number that we require for the argument is this angle here. And to get that, we're going to have to subtract from 2 pi, or subtract 2 pi, I beg your pardon, from that number, and we end up with negative 11 pi over 12. So the argument of z1 divided by z2 is negative 11 pi over 12. We'll put those two things together then. z1 over z2 is then 1.5, and then putting in the argument cosine of the argument plus I sine the argument gives us that expression. So in the same way as when we're multiplying, we have to be careful that the argument is a number between negative pi and pi. That will happen with division as well. Well, that's the end of this video, where in the next one we're going to be looking at loci. So we're looking at modulus definitions for loci.